Okay, so 14 is really the application of all or the word problems of derivatives. Okay, so first of all, it's important to understand what the derivative actually gives us because what I wrote down was this: the dy dx, the derivative, gives the rate of change in y with respect to x. And then I just wrote down some general examples. I wrote dh dt, or we could say h prime of t, could be the instantaneous rate of ascent of a person in a Ferris wheel. I didn't write the units down. I was kind of just wanting to make sure you understood what is the derivative finding a person's instantaneous rate of change in lung capacity. So these are just going to be word problems. So anytime you see the word rate of change, instantaneous rate of change, it's telling you take the derivative. Okay, so first of all, according to a psychologist, the ability of a child to understand spatial concepts is given by A equals 1/3 square root of t. T is the age in years, and we're going to focus on the years between 5 and 18. So find the rate of improvement. That word rate is take the derivative. All right, so first we need dA dt, and I would always, with rate of change, I would always use the dA over dt notation. All right, so if you need to rewrite this as 1/3 t to the 1/2, when we take our 1/2 times 1/3, that's 1/6, and we end up with square root of t in the bottom. If you need to take that through some extra stuff, that's fine. This is our general formula for this problem. Letter A says, find what the actual rate is when t is 9 years old. So we're going to plug in 9 in place of t. Well, the square root of 9 is 3 times 6 is 1/18. So this is just the rate of improvement when a child is 9 years old. To understand, this is the rate of improvement when the child is 9. And then the same thing when 16. What is the rate of improvement when the child is 16? Well, the square root of 16 is 4 times 6 is 1/24. Notice this is actually a little smaller number than this one. It's just, and if you kind of think about this, the older that you get, okay, how much are you, what's the ability, the rate of improvement? The rate is slowing down. And that's what we're going to kind of look at in B and C. Okay, show that the derivative is always positive. Greater than 0 just means positive. So if I'm looking at dA dt, what's the only thing affecting the sign is the square root of t, right? So I know the square root of t is always positive. Therefore, dA dt is also always greater than 0. Okay? So we always are able to understand more. The older that we get, the ability to understand is increasing with age. Okay, now, letter C, it says show that the second derivative is always negative on this interval. So then we have to take the second derivative. So I'm going to rewrite this first derivative, 1/6. Well, this would be t to the 1/2 in the bottom. So I'm going to move it up. So that's t to the negative 1/2. Then I can take the derivative sometimes this notation kind of messes with people. So just look at it and copy it down. It just means the second derivative. So how do I find the derivative of the derivative? Negative 1/2 times positive 1/6 is negative 1/12. That's a negative. Let's just do that. T to the negative 3/2 when I subtract my 1. We could just say negative 1/12 t to the positive 3/2 in the denominator. So between 5 and 18, t to the 3/2 will always be positive, times negative 1/12. This is always going to be less than 0. And this just means the rate, this is the acceleration, this is our second derivative. The rate is slowing down. So you learn the fastest when you're young. You're still learning as you get older, but the rate that you're learning is slowing down. You're not learning quite as much every year as you learned the year before. Because it's kind of just snowballs when you're a little kid, and then as you get older, you're still learning, but you're not learning quite as much. All right, example 2, another type of real world. I see this in like economics. If you ever take an economics class in college, they might ask about marginal cost. So marginal cost is basically just telling us how much it's going to cost to make one more item of whatever it is we're talking about. But anytime you see marginal cost, it's just the derivative. As soon as you see that word, it just means derivative. So sometimes just understanding all of the words that mean take the derivative, it's important. So once you see it's a calc problem, you almost always just take the derivative. All right. So the derivative of our cost function is the constant goes away. 12 plus 0.8 times 8 is 6.4. 0.8 minus 1 is negative 0.2. And that's our derivative. That's part A. B says find the marginal cost when 150 items are produced. So we're just plugging in 150 items, and when we plug this into this equation here, and because this is cost, this is in dollars, so this is telling us if we make 150 items, it's going to cost us roughly, this is interpret, this is the estimate of making one more. So the 151st item. So it takes so much to make all of our items. We made 150 of them. To make one more, it's going to cost $14.35 to make one more of these items. All right. So C is finding the exact value. What's the cost of making 151 exactly? Not the rate, not the marginal cost. This is just what's the cost of 150, because this tells us the cost of exactly that amount minus the cost of 150. And if we plug 151 into our original equation, subtract off the cost of 150 items, guess what? We get the exact same amount. Now, it's not usually that close, but it's usually within some dollars or cents. So this is a really good estimate. Okay, so sometimes we use calculus to help show this. Um, I guess the big thing is when you see the word marginal cost, take the derivative, and it's the rough estimate of making one more. All right, this is probably what I see more in calculus, is we end up starting with an equation and we take the derivative. All right, so if we have this picture here, this is remember drawing with a compass ever in geometry? What I'm going to do though, I'm going to draw this out. This is just a triangle where this is 9, this is 8, this is theta, and we want to figure out r. Write the radius in terms of theta. Well, this is a non-right triangle. What formulas can we use in a non-right triangle? We can use law of sine or cosine rule or sine rule. But to use the sine rule, we need to know both of these. And we don't. We want to get r in terms of, so that r equals the other information. So this means I'm going to use the cosine rule because I want r in terms of theta. So look at your cosine rule in your formula booklet. R squared equals each side squared minus 2 times each side times cosine of the angle. All right, I'm going to get r by itself. So that means I'm going to square root both sides. And I'm going to go ahead and, this is 81 plus 64. So I'm going to actually add these together. That's 145. Minus, multiply all these together. That's 144. Be very careful because these are being multiplied. This is all connected. You cannot subtract this. I have to multiply these two together first. All right, this is letter A. Then it says find the rate of change. That's take the derivative. That's dr d theta. The derivative of r with respect to theta. Okay, so when I take the derivative of this side, this is a square root. So that's 1 over 2 square roots. If you need to rewrite this using the 1/2 and go through all that, go ahead and do that on the side. I just think it's so much easier if you have a square root, just 1 over 2 square roots. Now, you always have to chain on the derivative of the underneath. So the derivative of a constant is 0. The derivative of negative 144 cosine. Well, the negative 144 is just a coefficient. The derivative of cosine is negative sine. So if I have minus 144 cosine, that'll be negative 144 times negative cosine. So it's really, oops, still need the 144, sorry. Okay. Now we can simplify this a little bit. 1 times 144 is just 144, but then I can cancel out the 2. So I get 72 sine theta over the square root of 145 minus 144 cosine. Okay, so I'm going to show you all the details on this last step here, but you still will need a calculator at the end. I'm going to draw out because theta is 60. And what's important with this, we had to take the derivative first before we can plug in theta is 60. in a 60-degree triangle, we have 1, 2, square root of 3. So if I want to find sine of 60, all right, so I would probably write this out, plug in your 60, because then you're going to get credit for plugging it in. Now, what is sine of 60? So y over r, so that's square root of 3 over 2, over the square root of 145 minus 144 times a half. So then we can say 2 goes into 72 36 times. This is 72, 145 minus 72 is the square root of 73. This would be all you could do if this were a non-calculator. But if you plug this into your calculator, you would get 7 point, and it's like 2999, so we're going to go 3 sig figs, it'd be 7.30. Now, all trig stuff, all calculus stuff, even though they gave us 60 degrees, we calculated that by hand. This is always considered radians per, what was the other? Measurement. Centimeters. I had to find it on my paper, sorry. And that's all.